Hi everyone, welcome to a new iProcess webcast. Today we will talk about cyclomatic complexity. What is it? Why do we measure it? And what is the relationship between cyclomatic complexity and testing effort? So let's start with the definition. Cyclomatic complexity, also known as McCabe's cyclomatic complexity, measures the number of independent paths through a unit, module, or detailed design element. It was developed by Thomas McCabe in 1976 to determine the stability and level of confidence in the code. Cyclomatic complexity is usually illustrated by a control graph, such as this one here. It basically means that you add a new path into your code execution every time you add a new decision. This control flow has a number of edges and nodes. The cyclomatic complexity can be calculated using the formula: edges minus nodes plus 2 times the number of unconnected parts of the graph. Typically, the number of unconnected parts is 1 if we measure a function. Here are a few examples. This graph here is the simplest option: 3 nodes and 2 edges. 2 minus 3 plus 2 equals 1. So the cyclomatic complexity here is the lowest possible. Now we add a decision to it and we get 4 nodes and 4 edges. 4 minus 4 plus 2 equals 2. The cyclomatic complexity increased due to the added decision. Now, let's add a few more decisions to get a little closer to reality. Here we have 8 nodes and 12 edges. 12 minus 8 plus 2 equals 6, and so on. There are also other methods to calculate the cyclomatic complexity, namely the predicate method or the topological method, which are both generating the same resulting number. Cyclomatic complexity gives us the following information. First, the complexity of the code. The higher the number, the harder it will be to understand and maintain the code. Second, the required unit test effort. The higher the cyclomatic complexity, the higher the number of unit test cases that have to be defined and executed to achieve branch coverage. For more details on unit test coverage, check our video in the description. According to Wikipedia, McCabe introduces the following categorization to interpret cyclomatic complexity. 1 to 10, simple procedure, little risk. 11 to 20, more complex, moderate risk. 21 to 50, complex, high risk. And a cyclomatic complexity over 50 is considered untestable code, very high risk. The automotive industry, particularly if we talk about safety-critical applications, recommends a cyclomatic complexity of not higher than 10. iProcess can help you with guidance, workshop moderation, and strategy definition for unit verification, component integration, and system testing. We are not only telling you what you did wrong, we can help fix it.